So electric universe and mainstream science are both wrong for the exact same reason. And it's kind of cool that everybody can understand what's going on here because I'm about to explain it to you. I know for all my new listeners and people who have just discovered this theory, this one's for you for the most part because it puts a big piece of the puzzle together. Hi, Celeste. You have thermodynamics. Now, thermodynamics is a very big field of science, but there are little aspects to it which stick out to me that I think people need to pay attention to, which are sort of ignored in both electric universe and mainstream science. And that's in thermodynamic phase transitions. Now, those people that have studied thermodynamics know that there are four basic phases of matter, four basic states of matter. You have your solids, your liquids, your gases, and your plasmas. So a solid is the molecules that make up a solid are arranged in irregular, repeating patterns that are held firmly in place but can vibrate within a limited area. This is your rocks, your diamonds, your seashells, dried bones, fossils, plastics. Those are the solids. You have liquids, which make the molecules that make up a liquid flow easily around one another. They are kept from flying apart by attractive forces between them. Like with water, the attractive forces are hydrogen bonds. Liquids assume the shape of their containers. So if you have a cup, the liquids will form right inside that container. They'll take the shape of the container. Gases are weird. Gases are the molecules that make up a gas fly in all directions at great speeds. They're so far apart that the attractive forces between them are insignificant. But what gases do, they not only take the shape of a container, but they fill the container. Which means if you have a bottle, like a soda bottle, clearly when you open the top, the gases will want to escape. But the water, the liquids, or the soda will stay put. So that's two different distinct properties of liquids and gases. So the gases will want to take up the entire shape and the volume of a container. So when you open up a soda bottle, though that CO2 that's in the top that releases the pressure, that's going to disperse throughout the entire room, but it's going to be very, very, very diffuse. And if you open the front door to your house, those same carbon dioxide molecules are going to disperse through the entire Earth's atmosphere. So one day, one of those molecules is going to be in China. But and then you have plasma. And at very high temperatures of stars, atoms lose their electrons. The mixture of electrons and nuclei that result is the plasma state of matter. So plasma is when the atoms have been flying apart. So you have the loose electrons and the loose nuclei of atoms, and they're flying apart, making positive and negative charges all over the place. This is a distinct state of matter. This is not a gas. Gas is where the atoms can be neutral, but a plasma is where they're charged. And think of like a lightning bolt. A lightning bolt is where the gas is, or the plasma is recombining into gas. That's why it's so bright. It's recombining. It's releasing energy because those electrons are falling back into the atom to make a stable atom, or a electrically neutral atom. But those are the four main states. It gets a lot more complex than that, but I just want to review that. And then you have the enthalpy of systems. Enthalpy basically is a fancy way of saying heat energy. So the enthalpy of a system goes up and down, but if you want to change the phase of the material, you add or subtract heat from it. So given a material's specific properties, if you add heat, it becomes liquid. If you subtract heat, it becomes a solid. Similar to like metal. If you melt down copper to around 1300 degrees Celsius and makes a liquid, there's a lot of heat content in there, so it's going to be a liquid. You can take copper, melt it down, and make a liquid out of it. If you heat it up even more, you can make it into a gas. If you heat it up even more, you can rip the copper electrons off the copper and make it into a copper plasma, which would be extraordinarily hot. And then you also have water. So say you have like an ice cube, you melt it, and then that liquid water is inside a pot, and then you heat it up in the pot, and you can make that water become a vapor, which then escapes the pot. But if you want to make a plasma out of that water, you want to rip the electrons off. I think what's going to end up happening though is that hydrogen and oxygen molecule that makes up the water, I think the hydrogen and oxygen are going to rip apart, and it's just going to separate completely. And then you'll have, you know, the positive or negative charged hydrogen atoms and positive or negative charged oxygen atoms flying around. But that would be a plasma, and that's an extraordinarily large amount of heat to separate that. And the reason why I wanted to review that is that these states of matter are what compose stars. All stars are made of all 4 states of matter. And that's what Electric Universe and mainstream science sort of just, they're da-da-das about it. They're total fucking retards. Sorry for cussing. But when you have an object that's made of plasma, and you understand what a phase transition is, what the different phases of matter are, it becomes obvious. The plasma isn't going to stay plasma forever. It's going to lose its heat. It's going to lose its enthalpy. That's what happens to objects in thermodynamics. When you put a hot object and you put cold material around it, or material that can absorb all the heat, that hot object in the center is going to lose its heat, and it's going to phase transition to a lower enthalpy, to a lower state of matter, to a less energetic phase. So stars are in outer space. They're not going to remain plasma forever. They're going to phase transition into gaseous material. What's going to happen to that plasma is what is happening to the plasma is that it's recombining into gas. That gas, that plasma, is undergoing plasma recombination. Those free electrons and free atomic nuclei are combining together to make stable, neutral gas. That's what happens to stars. And if there's enough of that combining of those ions together to make stable ions, which will no longer shine because they're electrically neutral, what's going to happen is they're going to become gas, and then that gas is still extremely energetic, and that gas is going to continue cooling and combining into even more complex molecules, and then it's going to become solid and liquid material. So what happens is that gas also goes in 2 directions. The gas giant it condenses into liquids, and that gas also deposits as solid material. Vacuum vapor deposition is what happens to the interior of the star when it forms its iron core. What happens is that iron vapor condenses directly to the center material, the center core, making a very, very huge iron-nickel alloy core. And that's what's inside the Earth. That's what's inside of Mars. That's what's inside of Venus. That's what's inside of Mercury. That's what stars do. They vacuum vapor deposit that iron in there. That's why it's so pure. We have vacuum vapor deposition techniques inside of industry, which make incredibly pure crystalline structures that we use inside of cell phones and computers and stuff. But that's why the iron nickel alloy is so pure. That's why meteorites are so pure. Is that star is what purifies and filters out all the incoming asteroids, and as it evolves, it forms its core in the center through vacuum vapor deposition. So that gaseous material goes to solid in the interior, and stuff that doesn't remain pure, it can mix with other elements and make liquid material. And the liquid material is super hot as well. That's what the magmas are, like lava. That lava is liquid rock. It's a really high energy rock still, which is still in the form of the mantle inside of the Earth. It's still cooling off to this day. And then eventually, that solid and liquid material, as the star reaches past ocean world stages and past Neptune stages, and it hits the Earth stage, the Earth stage continues cooling and cooling and cooling, and eventually completely solidifies because that liquid rock solidifies into solid rock. And when it goes through solid rock, we know what that phase transition is, because that's what freezing is. When we can see on the surface when when volcanoes erupt and lava seeps out from underneath the surface, reaches the surface. I think it becomes an extrusive rock. It solidifies on the surface on top of the ground, and that's what happens. It freezes. But I mean, freezes in terms of we think of water freezing, but yes, if rock is 1,000 degrees and it cools down to about 70 degrees, which is the ambient, temperature of Hawaii basically all the time, it's going to cool down. It's going to freeze into large lava fields. And we know that happens. That's the basic thermodynamic phase transition, liquid to solid material. And so what this means to electric universe and mainstream science is that we have stars doing stuff that's very basic, very easy to understand. They're not these exotic structures that need years and years of schooling with mountains of math equations to work out, with, studying with electric universe, on the electric universe side, mythology that goes back thousands of years. You don't need that. All you need to do is study basic thermodynamics. And basic thermodynamics dictates that if you have an object that's really, really hot and you have a heat bath, which is outer space, it's going to cool down in phase transition all the way to its solid form. But along the way, that a lot of the hydrogen and helium that it has will escape. That's why the majority of the mass is lost. And we know it's escaping because we can measure it. It's called solar wind. There's flaring. There's coronal mass ejections. And those stars, they lose their mass as they evolve, and they cool and collapse. And they transition to these forms. So when you see these astronomers call these objects planets, you should know better. These aren't just what's called planets. These are highly evolved stars that are in different states of matter. And the reason why they're in different states of matter is because they're highly evolved. It's basically circular reasoning upon something that doesn't even really require circular reasoning. It's just, this is basic information here. But all right, guys, I think I made this video long enough. Hopefully, when you guys look at a lot of the mainstream publications and electric universe videos and ideas, you keep that in mind. They sort of just, they don't look at the stars for what they actually are. They have a set vision or worldview of what they think they are, and then they form this really strange worldview that isn't required at all. This is like, you can do these types of phase experiments in your house. I don't know if you guys want to do this, but you can also make a plasma in your microwave if you want. But I'll go ahead and link a video of doing that on the bottom, but I suggest I suggest being very careful when you do that experiment. But all right, guys, or I should say demonstration. All right, guys, I made this video long enough. Peace.